All right, we're going to be moving on to 7.3, which is power-to-power exponent properties. And again, this is something maybe that you've seen before, but we'll do a little bit of review from yesterday and then dive right in. I've got about 6 problems that I want to work with you on today that'll help get you ready for the practice. And so yesterday we talked about product and quotient properties. And just as a reminder, you remember we talked about things like x to the third times x to the fourth. You remember when we're multiplying exponents that we do not actually multiply them, we actually add those. And so this would become x to the seventh. Another thing we talked about was the quotient property, which we talked about. So example, you'd have y to the sixth divided by y to the third. And so when you divide exponents, you actually subtract them. So we would end up here with y to the third. So those properties kind of go in line with this too. You actually continue to use them. It's a lot like any other form of mathematics. You just keep building on what you already know. But when we're talking about power-to-power exponent properties, we're talking about something like this. Okay, so let me give you an example here. So let's say we had x to the fourth, and we were raising that to the second power. So what I want you to notice here is this time I have a power here. I have an exponent, but I'm actually raising that to an exponent again. Okay, so that's the reason it's called power-to-power exponent properties. And so remember when we were talking about exponents before, for example, if you had 2 squared, that is the same thing as 2 times 2. Okay, this 2 is just telling this base that it needs to repeat itself twice. And so let's think about what we have right here in this example. We have x to the fourth, and that entire quantity, you notice the parentheses, is being raised to the second power. So really what we have, it kind of goes back to this property that we saw before. We really have x to the fourth times x to the fourth, okay? Just like 2 squared would be 2 times 2, here I have x to the fourth squared. So that's really x to the fourth times x to the fourth. So what happens now? I go right back to the previous property that I'd already talked about, where when I multiply exponents, I actually add them. And so watch what ends up happening. This becomes x to the eighth. Now, is there an easy way for us to get there without having to do this step right here? Well, notice what happens. If I have a power raised to a power, this really, my final answer I end up with is just simply this times this, okay? So when you multiply exponents, you actually just add them. But when you have a power raised to a power, you can actually just multiply it and get the final answer, okay? So when you have a power raised to a power to power, you need to multiply. And I'm going to use the raised dot because in algebra we don't use the x. That gets confusing. So again, if we multiply, we actually add. If we divide exponents, we actually subtract. And if we have a power to a power, then we actually multiply. So that should be a little helpful note that's going to help you with these type of problems. So let's dive right in. Let's look at some more problems here. I'm going to go ahead and clear my canvas. And let's look at a new problem. So now we'll look at 3y to the second, and that is being raised to the third power, okay? So now let's think about what we really have here. You really have this entire quantity, because it's in parentheses, being raised to the third power. So again, we said anytime you have a number right beside of a variable, that also indicates multiplication, okay? So another way we could write this particular one, and you don't have to do this every time, I'm just kind of explaining what you do here, is this 3, this exponent applies to everything in here. So we could also say 3 to the third power, okay, because that exponent has to be applied to the 3 too. We can't just leave the 3 out and just do the variable. Okay, so 3 to the third power times y to the second power, but again, that is being raised to the third power, okay? So now you can kind of get an idea of what you do. What you need to do is you need to apply this power to everything that's in here, okay? So let's look at this. 3 to the third power. What would that be? Well, that's the same thing as 3 times 3 times 3. So 3 times 3 is 9. 9 times 3 is 27. So this part right here would simplify just simply to 27. Now, what's going to happen with this y squared that is being raised to the third power? Well, keep in mind, I have a power that's being raised to a power, okay? So when I have a power being raised to a power, I know that I need to multiply. So I'm going to have y, but I'm going to have 2 times 3, which means this would be to the sixth. So my answer would be 27y to the sixth. Now let's look at this same principle with another type problem. Let's say we have x divided by y, again, still in parentheses, but all of that is being raised to the fourth power. Well, again, this fourth power applies to everything that is inside, okay? So because it is being applied to everything on the inside, I can look at this as x to the fourth power over y to the fourth power, okay? Why did that stay the same? Because I have x to the first here and y to the first here. And when I take 1 times 4, that gives me 4, okay? So again, this would be our final answer. And you're going to see a problem actually very, very similar to this problem right here. So that was a good example for us to be able to see. All right, let's add some more variables in all at the same time, and let's kind of culminate this thing here. All right. So let's look at 3 more problems. First one, I'm going to have x to the third, y to the second, z, and I'm raising all of that to the second power, okay? So again, I want you to kind of think of this in terms of the distributive property, really. You're distributing this exponent through every single thing in here, okay? So again, I'm really taking a power and I'm raising it to a power. So when I do that, when I have a power raised to a power, remember it is multiplication. So I'm going to have x, 3 times 2 is actually 6. I'm going to have y, 2 times 2 is 4. And then remember with my z, what is actually here, even though I don't see it? There's a 1 right there. So 1 times 2 would be 2. And folks, that simple and easy. There is your answer. Okay, 2 more questions. Again, trying to get a little bit more complex as we go to make sure we're getting everything covered. So we have 6x squared, y to the third, and that is all being squared over. You're saying, oh my goodness, wait a minute, I didn't sign up for this. All right, here we go. We got this. X to the 8th, y to the 5th. Okay, so again, this kind of goes back in grade school. Remember, please excuse my dear Aunt Sally. So PEMDAS, you kind of use the same strategy here. Okay, so we're looking inside parentheses first to see if there's anything that we can do. There's nothing really we can do inside parentheses. So now I've got to look at exponents. Okay, so all of this is being raised to an exponent, so I need to do that work next. Okay. So real simply, just like we've been doing before, think about distributing that to everything inside of here. So first of all, I've got 6 squared, okay? 6 squared, so 6 times 6 would be 36. Then I have x squared being raised to the second power. So I have a power raised to a power. So I'm going to multiply, which means that would be 36x to the fourth. Okay, then I'm going to have this power raised to a power. So y to the third raised to the second power. Again, I'm going to multiply. Anytime I've got a power raised to a power, I'm going to multiply. So I've got y to the sixth. And this is all still over this quantity that didn't really change at the bottom, x to the eighth, y to the fifth. Okay, so now it goes back really to what we learned on the first day when we were talking about product and quotient. Actually, I guess it's the second day. So now the 36 is just going to stay where it is. And now I got to think about these x's. Okay, so I have 4 x's up here on top. I have 8 x's on bottom. So again, think about how many would be left over, because when I'm dealing with a quotient, I've got to use subtraction, but I got to figure out where those are going to be left over. Well, these x's, the 4x's, right? Because 8 minus 4 is 4, but those 4x's are not going to be on top. These are going to cancel. That means my 4x's are actually on bottom. So I'm going to go ahead and draw me a fraction bar, and I'm going to put x to the 4th right there. Okay, now look at my y terms. I have 6 y's here, and I have 5 y's here. That means I'm going to have how many left? Remember, when I'm dividing exponents, I actually subtract. So 6 minus 5 would leave me with 1 y, but where is that 1 y? Is it on top or is it on bottom? Well, it has to be on top because I have more y's on top than I do on bottom. So that means my answer would be 36y over x to the 4th. All right. One last problem. This is not going to be as hard, I don't think, but it's something we need to look at. So now we have our last problem, which is 3x to the 4th, all of that being squared, times negative 2xy to the 2nd. Okay? So again, I've got to think about what I have to do first. I'm looking inside parentheses to see if there's any work that can be done inside the parentheses, and it doesn't appear that there's anything I can do right now. Okay? So the second thing I'm going to do is I'm going to look at exponents. And right here, sure enough, I've got an exponent that needs to be dealt with. Okay? So I'm going to take this exponent and I'm really going to kind of distribute it to both. So 3 to the 2nd power is the same thing as 3 times 3, which is going to be 9. And then x to the 4th power, and that raised to the 2nd power is power to a power, right? So I'm going to multiply. So 4 times 2 is going to give me 8. And then I'm multiplying that times this quantity over here. Now, I don't really need these parentheses. So really, I could take those off now and just repeat my problem, okay? And now I'm left with actually a pretty easy problem. Again, we're going to deal with these coefficients first. Remember, there's multiplication all in between this. So 9 times negative 2, a positive times a negative would be negative. 9 times 2 will be 18. Now I'm going to deal with the x. I've got 8 x's over here. I've got really 1 x over here. So when I multiply exponents, I actually add them. So I'm going to end up with x to the 9th because 8 plus 1 equals 9. And the only thing left over, if you will, is y to the 2nd. Okay, so this is going to be my final answer for this particular problem. So again, I hope this has been helpful. I'm sure that you're going to do fine on this practice, but I just wanted to touch base with you and kind of give you a few examples before you got started. Obviously, if you need help, just get with either me or Miss Wheeler, and we would be glad to help you any way that we can. All right, just reach out to us.